Hello friends, today I'm going to solve LeetCode problem number 211, design, add and search words data structure. So what we need to do in this problem is design a data structure that supports adding a new word and also finding if a string matches any previously added string. So we need to implement a a word dictionary class where we are going to initialize our object, and then in the add word function we are going to add this word to our dictionary, and then in the search function we are going to search for the word in our dictionary. So before that we need to make sure that our dictionary is capable of performing add word function and search word function with optimal time complexity. So which dictionary could we use to perform these add word and search word functions? So let's look at this example that we are given here and then see what we could do. Alright, so this is our example, and in this first word dictionary, which means that we are initializing our data structure here. So we initialize some form of data structure here, okay, and then we add a word to our dictionary. So we add the word bad to our dictionary. So this is our first word in our dictionary, and then we again add another word, that is dad. So we add another word dad to our dictionary, and then next we again add a word mad to our dictionary. So now we add a word mad to our dictionary. So this is our dictionary. We are not sure what this dictionary is yet, but let's assume it's some form of dictionary, some that has some form of data structure. It could be an array or a map or a set or a binary tree like dictionary, which is try in this case, or anything else. So let's assume it's one form of data structure, and now we need to look for the word pad. So just by looking at these words, these three words, we know that the word pad is not in the dictionary, right? Since we are searching for the word, it's not in the dictionary. So what do we return? We return false for this one. And in the next we are searching for the word bad, and we find the word bad here, right? So we return true. In the next search we are searching for this word, and what does this word has? It has dot ad. So dot basically here represents that any character, so it would be kind of like a wildcard search in this case. So dot could be a dot could represent a character a, dot could represent a character b, so it would then form a word bad. Dot could represent a character c, which would then form a word cat. Dot could represent character d, which could then represent a word that, and so on. So if we form any one of these words from this word, then do we have any one of these words? We need to do is check for the last two word characters here. So we do have ad, right, and it's preceding by b. So since it is being preceded by b, we know that this word exists. This we could find a wildcard search here, because when we replace, it's forming a word bad as well, right? When we replace the dot with b, and we have the word bad, we also have the word dad, which is also formed by replacing the dot here in this wildcard search. So basically we are able to find this word as well. Now what about this b dot dot? So in this case as well, we can replace these two dots with any characters. So we just have to look for the first character here, which is b, and it's of length 3, right? So we will search for the words of length 3. So we have here these words, and these words which are of length 3. So all of the words are of length 3, and now we check any of the words starting with b. So yes, this 3-letter word starts with P, which means that we found our word again. So we then return a true for this word as well. So we found all the matching words for each of our searches, and that's basically what this problem is asking us to do. Now, how could we solve this problem? Which data structures shall we use for this problem? Do we use array? If we are going to use an array, we will be storing each of our data structure in the form of over an index, right? So it starts from first, and as we add, the data will be appended to our array. So what happens when we are searching for a word which is at the very end of the array? So we'll basically start from the first, and then we keep on checking like each of the word, right, until we reach the last end. That would be the same case if we used a linked list. So basically the time complexity would then be O of n just for the search case. So this is O of n, and this would also be O of n here. So now that we know that this would be a huge time complexity while we search, so what could we do is we are just going to search for a more optimal data structure. So the next okay, let me just clear these things. So what could be the next optimal data structure in this case? So what we could do is we could either use a set or a map. If we use a set, we could just search for the word in O of 1 time complexity, right? Similarly is in case of map as well. So we could either use one of these tools, but what am I going to do is I'm just going to use the set because it's more simpler. And we could also use try. So this would be also one of the good data structures that we could use, but for this video I'm just going to use the set creative, and I'll add the solution to my code that I have performed using try in the description below. So now let's get started with the set. So what are we going to do is this whole data structure will be a set. Okay, all right. So now this data structure is a set here. So now what we can do is we start from the search. We have already added our data, our 3 words into the set, and we could do that using set.add function. Now to search as well, what we could do is we could check directly that the word is in the set or not. But what in case we have a dot in the word? So if the word has a dot, if the searching word, if the word we are searching for has a dot in it, that is when we need to perform a more complex search, that is a wildcard search. So in that case, what are we going to do is if the word has a dot in it, then we will first of all look for only the words which is of length equals to the word we are searching for this case we are searching for this word .ad, and the length of this word is equals to 3, right? So we will now compare this word with only the words which are of length 3. So since all of these three words are of length equals to 3, so now what am I going to do is now for each of this word I start by checking the first character, and since this first character is a dot itself, so that doesn't matter what character it is. So next I'll move to the next character, and then I check this next character and this matches, and then I go to the next one, and the third the last character also matches, right? So we found our word. But what in case this was a different character? Suppose this was E, then this third character would not match with this one, right? So in that case, we now move to our next word with the length equals to 3, and then we'll again perform the same operation, that is, we perform now character matching. So that is how we are going to do this problem. So I'll just repeat once again. So if the word that we are searching for doesn't have a dot, we'll perform word match. So we are just directly searching in the set. If it has a dot, then we will be performing character wise search. So that's it. Now let's start coding. So our data structure here is a set. So I'll create a dictionary which is a set. Alright, so now we have our dictionary, that's a set. Now we need to add the word. So to add the word to our set, all we need to do is just add it to our dictionary. Add the word. Okay, so now we have added the word. We need to search the word. So for searching the word, we need to check if the word has a dot in or not in it. So if word dot index of the dot in the word is not equals to -1, that is, if there is a dot in the word, then we are going to perform a character wise search, right? Okay, so we are going to perform the character wise search. Else what are we going to do is we're just going to look in the set. So return set that has the word. Okay, so now for character wise search, we are going to take all the words that are of length equals to this word. So now here in our dictionary, so we iterate over each of the word. Okay, how do we represent that word? Added a string of these that. Okay, so each of the strings in the dictionary, if the string length is not equals to word length, then we are just going to continue. Else what we'll do is we'll now perform character wise search, right? So for let c of string, if c equals to dot, then we just continue. Else what are we going to do is check for each of the characters, right? Else if c is not equals to the word at that index. Okay, so we need to use I equals to 0, I is less than I plus plus, and this would be word value character at index I, and this would be word at index I is not equals to the character at index I in the string. Then we break from the loop, else we keep continuing. Okay, so let I, and then here let's check if I equals to the length of the string, that is it has reached the final character, which would mean that we have been able to find each of the character in the word in the string in our dictionary. So that is when we are going to return true, because we found the word. So let me explain once again what I'm doing here. So what I'm doing here is, first of all, I look for the if the word has the character dot in it. If it doesn't have it, then we go here in our else loop, and that is when we just check for the word in our dictionary. So we are just looking in our dictionary if the word is not present or not, and we just return the value returned value that we get. Else, if the word has a dot in it, then we need to perform character wise operation. So for each of the string in a dictionary, if the length is equal, that is only when we perform the comparison. So if the length is equal, then we compare the both the words, and that is by performing character wise comparison. So if the character in the word is equals to dot, then we just continue, because it doesn't matter what the character at that same index is in our string, right? If not, then we are going to compare the character at both the strings, and then if those are not equal, then we just break out of this for loop and we continue with the next string in the dictionary. If not, if we are able to find all the characters in this word, that would mean that our index I has reached the last index, right? That is exceeded the length of the string. So that it will be when I will be equals to the length of the string, and we are returning true because we found each of the characters. Else we just keep continuing, and if we didn't find anything, then what we'll do is finally return false. Okay, now let's try to run our code and look for any errors if we get. Oh, all right, so it passed. Let's submit it now. Great, so this is how I performed this solution using a set as our text structure for the dictionary. I have also created a solution like donor solution using try node. So just give it a look, because this is also a very good solution. So yeah, talking about the time complexity of this solution, adding a word is a constant time complexity. And now searching for the word, if we are searching for the word without using this wildcard, that would be just constant time complexity. But since we might also need to perform a wildcard search, so in this case we are iterating over each of the strings in the dictionary. So if the length of the dictionary is n, then that would be O of n, and also we are iterating over each of the character in that string, right? So that would, if the length of the string is k, so our total time complexity would be of n times k for the search operation. Now what in case of try node? So if we use try node, the adding function would be, since we are adding the word character by characters, and if the length of the word with the maximum length is equals to k, then this would be O of k time complexity. And the search function, so in case of search function, we are searching for each of the word like one character at a time, so that would also be O of n time complexity in the worst case. And the space complexity for search function would also be O of n, because we are using a recursive call, and that would consume some space on our stack, right? So yeah, hope you like this solution. Let me know what you think about this solution in the feedback in the comment section below. Thank you.